Hello, everyone. Let's just wait a few more seconds so that other people can join us, and we'll start the lecture. Meanwhile, you can take your seats. We have a lot of vacant room here in the front row. Feel free to get closer. I assure you that the view here is great. Um, Amazing. So, good morning, everyone. Thank you all for joining me. It's great being here today and meeting you, or e-meeting you, unfortunately. Even though it's not a live session, I'll be available here. I don't know, wherever the chat is, I'm available on the chat for any questions that you might have during the lecture. So please feel free to reach out, ask those questions, and I'll be here to provide you with answers. I will also share the slides of this lecture and the Colab notebook with live examples of automated EDA and the usage of those tools, and it's for you to review. So it will be ready in 3, 2, 1, boom. So you have it in the chat. Um, if you have any questions also about the slides or the Colab notebook, feel free to ask them. So my name is Nir Barazida. I'm a data scientist, as you can see, at DugZub, which is a platform for data scientists to work together in teams in a way that they can scale their work. And I think that with that, we're ready to get this show on the road. And today we will focus on one of the hottest topics in the past 2 years in the data science ecosystem, which is Auto EDA. Many tools and features emerged to automate the process of EDA, and we can see a clear trend here. For example, we have Pandas Profiling, which is a Auto EDA tool. It's an open source tool. It was released during 2016, and in its first 4 years, they released only 6 new versions. However, since the late 2019, they released 26 new versions with new features, and this is crazy. We also have a lot of paid tools such as DataPine, Tableau, Sisense, and many more. And it's a clear trend, and a lot of data scientists are adopting those tools in their workflow to easily understand the data set at hand. So, our agenda for today. We will start by defining what is explanatory data analysis, what can be automated in the process of EDA, and last, we will learn the usage of brand new features of two powerful open source tools, which is Pandas Profiling and Sweetvis. And with that, let's start by defining what is EDA. EDA is the process of trial and error in uncertain space, our data, with the goal of finding insights. We can do it in various ways, from plotting the data in charts, checking for feature correlation, check for missing values, or apply any descriptive statistic method at our disposal. It usually happens in the early stage of the data science lifecycle, although there is no clear cut in our workflow between data exploration, data cleaning, or feature engineering. So at least let's have a clear definition of the two. The statistician J.W. Turkey made a distinction between descriptive and inferential statistics. In exploratory data analysis, attempts are made to identify the major features of the dataset and generate insights for further investigation. Where in confirmatory data analysis, CDA as I call it, attention is focused on model specification, parameter estimation, hypothesis checking, and firm decisions about our data. But where we as data scientists feel the pain when performing EDA? First, I would say that EDA is very checklisty process. In most cases, when starting to explore the dataset at hand, we will use the same set of methods with minor changes, making us copy and paste our code from previous project and tweaking it by the dataset at hand. And this workflow involves modification to many lines of code, making it error prone. It will consume our valuable time and make us deal with developer software issues rather than focus on our research as data scientists. And even though this process is repeatable, checking one box after the other, and it seems like a good candidate for automation, can it really be automated? The fundamental nature of machine learning deal with variable conditions that are hard to generalize and automate. Therefore, only the process can be automated, but it can't replace critical thinking. It just means that we can follow the best practices in fewer lines of code. And by adopting automation to our workflow, we will gain valuable advantages. It will enable us to skip the simple yet time-consuming tasks and focus our work on solving the core problem at hand. It will also be will save our time and the time that's saving from I'm sorry. It will also save our time and will enable us to scale our work. And a simple example here will be that by automating 50% of our work, it will enable us to produce 150% output. And last, we will have quality control. When using reliable tools that were written by experienced developers or in use by a variety of data scientists, we can have more confidence in the product that we produce. However, automation is not all sunshines and rainbows. It has its dark sides. Using automation tools can induce a false sense in the data scientist that is not responsible for his outcomes. And this is not true. We should remember that these tools are here to help us in the process and not replace us. Yet, another side effect that might occur that we will lose the ability to manually handle and do the automated steps. First, in my opinion, the most important thing here is that we need to understand what's going on behind the scenes. And once we will know how this process enables us to produce those results, it will enable us to better understand the output and gain the insights, the deeper insights. And secondly, we still need to have the ability to deal with edge cases and solve them manually. Last, we'll need to avoid the blind spots that are caused by automation and challenge the provided outputs. And as my good old friend is saying, with great power come great responsibility. Use the automated tools wisely. Thank you, Spidey, for that. And with that, we will move on to the second part of the lecture, which is the live example. And in this part, we will cover the latest features and usage of two powerful open source tools, which are Pandas Profiling and Sweetvis. We will check how to generate an EDA report and check what the report contains. We'll create a report that displays the distribution of the target variable versus all the other features. And lastly, we'll generate a report that compares two different data sets. And in our case, the train set versus the test set. So let's move on to the Colab environment. And in this example, we will use the Titanic dataset. The reason that I chose this dataset is because it's commonly known and it will help us understand the output of the report easily. I will start by importing the data from DuckSub. It's already split to train and test set, where an important note here that the test set don't contain the target feature, which it's the survive. And the first package we will use to generate an EDA report will be Pandas Profiling. And Pandas Profiling generate a profile report, an EDA report, from Pandas data frame in an HTML format. The report has an extensive description of each column using quantile statistics, descriptive statistics, and it also shows us feature correlation, missing values, and additional valuable information about the data at hand. To install it, we will use pip. And if you're using the Colab environment, I highly recommend upgrading the current version because the Pandas Profiling team keep releasing new updates and features that will be valuable to you to use. And to generate a report, we will use the profile report method. And let's see what the flags here represents. So first we have the DF, which is the data frame that we want to generate the report on. We have the title, which is the report title. In this case, will be the Titanic dataset. The exploratory flag here represent the deeper exploration and the usage of all the Pandas profiling abilities. So if you want in-deep report, use this flag and mark it as true. The data set will be a dictionary variable with metadata about the profiling report, such as a description, who created the report, at what date was the report created, a URL to the data, a link to the data. And the next one will be the sensitive. And when working with sensitive data, this option masks non-aggregative data in the report, and it will simply not show the sample or the frequency, and anything that any tab that contains the data will not be shown. And last, we have the HTML, which is the HTML, the report HTML configuration that you can change and tweak. I usually use the default settings, but it's for you to choose. And let's now generate a report and explore its content. I will start by saying that in this lecture, we will not cover all of the information that we have in the report, just the main features here. And you can use this notebook and explore it in depth later on. I highly recommend doing it. And now to the report. So the first section is overview, and it stores metadata about the data, such as the number of sample, the missing values, the duplicate rows, the features type, and other valuable information. And here in the sub-tab of the overview is the warning, which is very valuable to us. And this is where you can see all the warnings that we have about the data set in one place, like high cardinality, missing value, uniform for uniform distribution, and others. I added a link in the notebook with all the warning and examples for you to see. And let's move on to the next section in the report, which is the variables that has information about every feature. And now I would want to explore one categorical feature and one continuous feature and see how Panda profiling present them. So for the continuous, I will choose the age feature, and we can immediately see here that this feature has a warning for missing value, and it's because it has about 20% of missing values, and this can be very valuable to us as data scientists to know and understand. And we have the basic statistics and the bar plot here. And if you want to have the advanced statistics, we should simply click on the toggle details. And here we have the quantile statistics, such as mean, the quantile, the range, and also the descriptive statistics, such as standard deviation, the mean, and the variance. We also have an histogram of the feature, the common values and extreme values, which are pretty self-explanatory. And that's pretty much it. I think it has a lot of valuable information for us when talking about a continuous numerical feature. Moving on to a categorical feature, I'll choose the cabin feature. And here we can see immediately three warnings, which is the cardinality and the uniform. And for the cardinality is for high number of distinct values, and the uniform is for variable that this variable is uniformly distributed. We can check here the bar plot with the number of appearance of every category, which is also very helpful for us to see. And we can see that there is a distinct variable here, which is the other, that appears a lot. And by clicking on the toggle details, we will see the advanced exploration, the number of categories, and a sample of this feature. Under the categories tab, we can see the count and the frequency of the categories with a bar plot. Once again, very easy to consume the data. And we have another two tabs, which are very new features and advanced feature for text analysis. In this case, this is not text, but if you're going to use NLP data set, it will be very valuable for us. So we have here the word and the characters that are explored here in depth. Next, we can see the numeric feature and their correlation Next, we can see the numeric feature and how they interact in a scatter plot. And for example, we can see here the age and the number of siblings that survived. And you can easily see that as the age goes higher, the number of siblings that survived is lower. Once again, a lot of valuable information and an easy way for us to consume as data scientists. Next, the next element will be the correlation of numeric features. And as we can see here, we have the number of correlation presented in the heat map. And for every correlation, there is an explanation and what is represent. So for Pearson correlation, we have the explanation for Pearson and other correlations. And the following is the missing. The following feature here is the missing values, and here we have the variety of plots. And for me, the two most effective one are the metrics that enable us to see where we have the missing values in the data sets. So if we have a lot of missing value on the top or at the bottom, or it's spread throughout the entire data set. And the second is the Denot-Grom plot that shows us if we have missing values in more than one features for a simple or the same row. And this is also a lot of valuable information for us as data scientists to see. Maybe we have a lot of rows that are missing values in a lot of features, and we should simply either drop them because they don't contain a lot of valuable information, or see how we can fill those missing values. Unless we have the sample of the dataset. We can now simply save this HTML report to file and share it with our team or our stakeholders and easily present insight about our dataset. And this is, once again, very valuable. Next, I would want to continue to one of the latest open source tools for auto EDA, which is Sweetvis. And it takes Sweetvis simply takes a pandas data frame and create an HTML report similar to what pandas profiling has to offer. However, it has two additional features that are very useful. The first one is the ability to compare between two data sets. In this example, we'll see how the test set distributes the distribution of the test set comparing to the train set, and the visualization of the target feature distribution versus all the other features. We will start by installing the package with pip and import Sweetvis as SV. And as we can see, creating a report is very similar to pandas profiling, but here we can see that we also need to state the name of the target feature, so it will visualize it and this distribution next to all the other features. This is not mandatory, but I highly recommend also using it. And let's now see how the report looks like. So at the top of the report, we can see metadata such as number of samples, number of features, how many of them are categorical, numerical, and text. An additional feature that Sweetvis has here is the association of features, which including also categorical features. And if you're going to click on it, we will see that we have here a grid with a variety of shapes and what those shapes represent. So the squares are categorical association, which is uncertainty coefficient and correlation ratio from 0 to 1. And the uncertainty coefficient is asymmetrical, approximating how much of the element on the left provide information on the element in the row, and this is very valuable to us. And the circles are a symmetrical numerical Pearson's correlation from -1 to 1, which is the basic correlation that we all know with presented in a heat map. And the trivial diagonal is simply left blank for clarity. And as we can see in the legend, the dotted line provides us information on the target feature, and it will be presented in all the plots of all the other features. And let's now see how the Sweetvis present us the features. So for categorical, let's see the P-class feature. And we can see here the appearance of all the categories with the percentage of survival in each one. And this is very, very cool. And we can see immediately that in the first class, the mid class, we have a lot of survived people. Most of this class survive, approximately 60%. And this is very valuable to us to understand how the class affect on the survive rate. The rest of the report is pretty similar to pandas profiling, and I leave it to you to explore later on. I would like to move on to another cool feature that Sweetvis has that lets us compare between two data sets. And as I said, we'll try to compare the train set to the test set. And as we can see, all the plots now contain the distribution of both data sets next to each other in a very easy to consume way. Notice that the test set don't contain the target feature, but it still doesn't prevent from Sweetvis to only present the distribution of the target feature on the train set. And in this way, we don't need to generate two reports, which one of them will be the comparison between the two data sets, and the other one is the distribution of the target feature, the target variable in the train set. And this is very valuable to us. And not just that, Sweetvis also let us to compare the distribution of two categories in a feature with the rest of the features. So to better understand what I just said, let's take the sex feature and see how the male and female categories are distributed in the dataset. And as we can see here, we can see how many male and females survived the Titanic. We can also see the division between the classes, the distribution of their age, and many, many more valuable information that also will help us, enable us to feature engineer and create a new feature using two other features, or see how it impacts our survival rate and improve our model. The same as Pandas profiling provide us, we can also save the Sweetvis report in an HTML format and share it with our colleague, our teammates, or our bosses and stakeholders. And unfortunately, this is all the time that we have for today. I highly recommend going over the notebook and explore it in depth and see all the features and usage of those two tools. They're highly valuable to us as data scientists and can help us in our workflow and improve our productivity. I added another section at the end of the notebook with frequently asked questions that might be helpful for you, like how to create a report for image dataset and for text dataset for an NLP problems. And to summarize what we covered today, I would say that the field of auto EDA is growing very fast and can help us improve our productivity and gain valuable insights about our data in few lines of code and basically improve our model. I believe that more and more tools and features will emerge to improve our workflow, and not only in the EDA field, but in the entire ML pipeline. And if you have any further questions or want to join me on this crazy ride of building the next GitHub for data scientists, I welcome you to join me on my Twitter and LinkedIn pages that are now on the chat. It was great being here today. I want to thank Pike and Israel for having me, and especially to Sim. Thank you very much, Sim, for everything that you're doing. I wish you all the best of luck and fun EDA. And that's it for me. Bye-bye.